Hi, this is Chris, and the purpose of this video is to cover concrete column design in ENERCALC 3D. First, I'll just come up to load cases and show that I have some cases already defined. I've populated those with load items already, and load combinations have been defined. And notice that I have ACI load combos generated. They're set to run P-delta analysis, and they're set to be used for concrete design. So I'll just say OK here. My model is no longer solved, so I'll run the analysis and then say close. What I'd like to do is I'd like to focus on this one column that's in the foreground. So let's just pre-select that one and then come to the concrete menu item and then RC materials to begin with. Notice here that we see the materials that have already been defined in the model. These materials have been defined and possibly applied to certain members for their stiffness properties for the analysis. But when we come to the concrete and reinforcement strength dialog in the concrete menu, what we're seeing is not stiffness properties but strength properties. So here we can see that the concrete 4 that I've assigned to all these members is going to be associated with a compressive strength of concrete of 4 KSI, a yield strength for main reinforcing of 60 KSI, and a yield strength for ties or spirals of 60 KSI as well. So nothing that needs to be applied in this particular dialog. I'll just click cancel. Back to concrete. Design criteria. Here I'll just point out that we're going to visit only those items that are either general or that have specifically to do with concrete column design. So we'll start with model design criteria. The first decision here is the design code, and we'll just leave that set to ACI 31811. Then notice that there's a whole category here on column design parameters on the left. And on the right, there are some parameters associated with beam design and with concrete slab or plate design. We'll ignore everything off to the right for the purposes of this exercise. We'll just focus on the column design parameters. So we can set a minimum and a maximum reinforcing ratio, which I'll leave set to 1% and 8% respectively. The next 3 items are having to do with precision of the analysis. I'll leave the exact details to the user's manual, so you can look those up if you want more information on those, but I'll just accept the default values that we have set for neutral axis steps, biaxial angle steps, and axial capacity steps. The next option is called Exclude Concrete Displaced by Steel. In practice, we would want to select that option, and I'll leave it selected, but it's there as an option in case for some reason you were trying to check some sort of say a published value in a textbook or in a journal where that practice may not have been used. And so in order to calibrate the results of the program with something that didn't assume or neglect the concrete displaced by steel, it's here as an option to select or deselect. Notice that there's an option to always use 1.0 for CM, or we can just uncheck that box and let the program calculate the values of CM automatically. This drop box is used to identify the sustained load that's used to compute beta D in columns, and for our example I'll choose the combination that's called dead because that's what I consider to be our sustained load. Then there's an option to ignore the compressive force in concrete shear capacity. Generally, we would want to consider the compressive force because it's beneficial to our designs, but again, this is provided as an option in case you wanted to try to compare to published results where the basis was to ignore the compressive force in the shear capacity. There's an option to check capacity at column ends only. I don't need to do that. I'd like to check capacity all along slices on my columns, so I'll leave that one deselected. And then finally, there's an option to compute the minimum moment based on PU times the small distance. If we deselect that option, then the program considers the minimum moment to be the smallest calculated applied moment in the columns. With all of those model design options set, I'll click OK. And then I'll come back to Concrete, Design Criteria. We'll skip Beam and go directly to Column Design Criteria. There's a default column design criteria already defined, and I could use that one, but for clarity, I'll just create my own. I'll call it My Column. These checkboxes ask, does the column stiffness about its X direction contribute to resistance to sway? Yes or no? In this case, I'll say that yes, this column is a sway column in both directions because there's no shear walls or braces. It's clearly a moment frame in both directions. The note up here indicates that we can enter 0 for LUX and LUY if we want the program to use the member's length as the unbraced length. So I'll rely on that for those two. There's some theoretical value to the K factor. In this case, I'm just going to use 1.2 for both KX and KY without much basis. How many tie legs cross the shear plane? I'll say there's 2 legs. And the tie size, I'll set to number 4. The cover to the tie, I'll assume to be 2.75. What bar sizes do we want to have considered? Well, let's say I'm willing to use bar sizes as small as 6 or as large as 9. And then we have some options for bar layout. Bars can be placed on all sides or on the major or the minor sides, or they can be spaced equally around the column. I'll use the option to space them equally. The last option is with regard to confinement. We need to specify whether it's a tied or spirally reinforced column. In this case, I have rectangular columns, so I'll say that they're tied. Now with my one column in the foreground selected, I can make sure that I'm on this line 2. I can check the box that says Assign Active Criteria to Selected Members, and I can click Apply. I'll reselect that column because I have more assigning to do. That was column design criteria. The next thing that we can do is include or exclude elements from the design. What we might want to do is exclude everything other than the one column that we want designed, just for efficiency's sake. So what I can do is click on the screen and then invert the selection set, and then come back to Concrete and Design Criteria, Exclude, and I can say I want to exclude the selected elements from Concrete Design. This will apply to selected members, and then I can say OK. This one column is the one that I do want to have included. It probably already is included, and there's a table down below that we can use to review, but just to stay in order, what I'll do is come back to Design Criteria, Exclude Elements, and here I'll choose the option to include the selected member and say OK. So that removes all doubt that this one column is to be included and all of the others are going to be excluded for this design. The last item in the Design Criteria menu is cracking factors. This dialog allows us to specify a percentage of the gross stiffness to be considered in the analysis, and the note reminds us that ACI provides some guidelines on that. So I'll use the factor of 0.7, and I'll say that I want it to be applied to selected members, and click OK. The next item is called the Assign item, and for our purposes we would come to Column Design Properties. And we really have nothing to do in this particular case because we've already assigned everything that we want to the one column that we're going to design. But you can use this to assign established properties like design criteria or exclusion status and cracking factor to any of the members out here in the model. So I'll just cancel out of the assign column design properties dialog for now. The next item is design input. And if I open the member input table, here we can see a listing of all the members that are in the model. If we skim down through the exclusion column, we can identify the one that's included. That means member number 12 is the column that we've picked in the foreground. We can see whether the members are either columns or beams. We can see the design criteria that applies to each member. So we have design criteria number 2 assigned to our one column. And then we can see a cracking factor. Now, the member class can be changed with the drop-down. The cracking factor can be edited directly, for instance 0.7, and then click in another cell to leave that value there. The inclusion or exclusion can be modified by the drop-down. And then these controls up above allow us to select and assign column design criteria. So for the column number 11 that's currently selected, if I wanted to assign design criteria number 2, I could just select it and then say apply to selected rows. It looks like I'm selected on a cell. So number 2 and apply to selected rows. And now we can see that that changes as well. So that's a thorough look at the concrete member input table as pertains to column design. And just remember before we leave here that the only member that's currently selected for inclusion is the column number 12, the member in the foreground. So I'll click OK. That was the design input item. At this point, we've provided all the information that's required so we can perform a design. The only thing we need to be careful of is this message down here that says because of some of the other changes that I've made to the model, the analysis results were not current. So we wouldn't get far with a design. Now that analysis results are current, we can come back up to Concrete in the main menu and then choose Perform Design. And now the design is complete. So we'll say Close, back to Concrete, and now we can start to look at some output. So in the Design Output item, notice that there's Reinforced Concrete Analysis envelope. It's important to understand that this is an envelope of all of the combinations that were marked for concrete design. So we see maximum and minimum major moments and an absolute value for major shear. And then for each of those three, we can see the load combination number for reference that created that design value. Notice that the load combination drop-down is provided here for reference, so we can determine what load combination number 6 actually is, and look that one back up if we want to. But remember, this is just here for reference because this is an envelope, and so changing the currently selected load combination doesn't change the results in the envelope itself. So I'll click Close, come back to Concrete, Design Output, and here we can look at Reinforced Concrete column results. We only have one column designed. It's member number 12. Stretch things out a little bit here so that we can take a closer look at the section label. This has meaning or some sort of a syntax that tells us how many bars and of what size and what clear cover and so on. The important thing to understand here is that for right now, the unity check is showing that we have a problem because the ratio is greater than 1. It's governed by load combination number 6, tells us where the critical location is. the P and the M values, the factors, the value calculated for beta D, and the values calculated for CM. So we'll have to revisit this column and see if we can figure out something a little bit better for that design. For now, I'll just click Close. If I come back to Design Output, notice that there are quite a few options under flexural axial interaction. The sections provides the specific information for each of the sections that was tried. It tells us the geometry, the material properties, the bar sizes, and so on. If I come back to concrete, design output, flexural axial interaction, notice that there are some options to open tables of interactions. So here we can see that it's the PMX positive interaction table representing compression on the top of the section. We can see values of phi-PN, phi-MN, eccentricity, maximum steel tensile strain, and the value of phi that's used. Similar for the other tables that are offered. Back to concrete, design output, flexural axial interaction. The last item is to print interaction diagrams. So this can be a handy way to document the different sections and the different patterns of rebar and sizes of rebar that are tried. I'll click Close to dismiss that. Back to concrete. That's all the information that's available in flexural axial interaction. Regarding column design, we could take a look at member shear results. Here again, it's important to understand that ENERCALC 3D concrete design for shear is always based on an envelope, so we can take a look at material strengths, stirrup size, number of legs, an applied shear, an axial load, a stirrup or tie spacing, and a phi-VC value. And again, it's based on the envelope of all the design load conditions that were considered for the column. That's all the information that's relevant to concrete column design in the design output section. Take a look at diagrams, reinforced concrete member envelope diagram. We can choose to look at, say, the moment or shear envelope or required flexural or shear reinforcement. Let's just take a look at a moment envelope. We'll choose to draw diagrams on all members and then say OK. If we snap into a front view, it's a little easier to see that we have a diagram on that member. Now we'll reset the model, come back into isometric view. The last thing that we'll look at is the reinforced concrete report. If I choose this item, first I can select which items I want to have included in the concrete design report. And then when I say OK, I can see what I'd be able to print for a report for this particular column. So as we can see, we have an interaction that's outside the diagram, and we saw that we had an overstress situation. This would be a case where I would need to go back and take a closer look at the column design criteria and see about increasing the bar sizes that were allowed to be considered, or changing the bar layout, or it's possible that my little sample model here is just overloaded and we might actually need to reconsider the column sizes that I've chosen. The last thing I'll mention is that there is an RC Tools item here at the bottom of the menu. We did cover this in the reinforced concrete beam design video, so if that's of interest, please take a look at that one. Not an awful lot here that's of interest for concrete columns, other than the fact that you may want to visit the K calculator so that you can calculate values to use for your column designs. So hopefully that's been a helpful look at reinforced concrete column design in ENERCALC 3D.